All right, welcome to the notes for 11.2, parallelograms and triangles. We're still going to do area formulas. So we're going to be getting a bunch of formulas, and you are not going to have to memorize them per se, but you will have to be able to identify and match them up. So you will have to identify that if it has pi in it, it's for a circle, or that, a triangle is this one, be able just to match them, and then you'll have the formulas available to you. So it's not so much as a memorization as just be able to recognize, or if that's the same thing to you, then maybe do. All right, so parallelograms. So parallelograms, recall, are kind of like a shifted rectangle. They still have symmetry to them, and they still have what we refer to as a height. Now this height or this altitude may be inside of the parallelogram, or it may be outside the parallelogram. So it doesn't matter where it moves. If it moves horizontally, it's still the same value anywhere it goes. The base is whatever side the height connects to, so it would be from here to here would be the base, or even if you had the height drawn outside the parallelogram, it's just like cutting off the left end and attaching it over here, so that's why you form actually a rectangle again. So the area formula for a parallelogram should look very familiar. There's the base times the height. So because the parallelogram and the rectangle are related to each other, they do have the same formula. The next one is the area of a triangle. Now it depends on what kind of triangle you have. If you have triangles with right angles, or something, even if it's not on the side, even if there's a right angle in it like this, even if the right angle is off to the side. So if there's a right angle in it, there's one formula to use. So again, this is the base and this is the height. Or this whole thing is the base and this is the height. Or with the third version, the height is the straight up and down, and the base is just the solid side of the triangle. The area formula is base times height, because we're still using the same information like we did for parallelogram. However, it's easiest to see on here because we are taking the parallelogram or a rectangle and we're cutting it in diagonally. We divide it by half, or some people say 1/2 base times height. Either way, it's the same thing. Now, if you didn't have for a right angle, but perhaps you had something like this, where you have one side, another side, and an angle. Okay, this is actually somewhat of a version of a parallelogram. It's just cut in half again, so you will see dividing by 2. The area is side A times side B times sine of angle C, and dividing by 2. So it's like a side angle side for the triangle. You have this value here. So if you had a triangle like this where it was like what, 5, 8, and this was 96. You would do, doesn't matter which one comes first, the area would be 5 times 8 times sine of 96 and divided by 2. So we could do some other stuff to get other information, but if there's a straightforward formula, why not use it? Okay, so as a decimal, that would be around, calculating it would be about 19.9. And again, whatever your units are, it's going to be unit squared. Now with these formulas, we're going to ask you to, apply some of the other stuff you've done. So the area is 60, so area, I have the shape of a triangle with a right angle, so I'm going to go ahead and use the triangle formula with the right angle. All right, area is 60, so my 60 goes in for my A. What is the base value? So I don't know the base, but I know the height is 15, and I'm dividing by 2. Okay, so you are going to be expected to work backwards and forwards, so plug them in straight away and get the total area, but also be able to work backwards and figure out a missing part. So you can cross multiply 60 with the 2. So the base is going to be 8 inches. So this is a work backwards problem. Okay, so working backwards, being able to figure out missing stuff. Now again, this next shape is a parallelogram. Area is base times height. Now I have my base here, but I don't have a height. So the height would make a right angle. I should have given you, so write in on this side what I meant to do. Write in that this side is going to be 8 centimeters. So that I should have given to you in the problem. So if it's already there, great. Means I fixed it. So for this, I want to figure out my height here. So the slant is not the height. I want to figure out my height, which means I have SOHCAHTOA. I can do SOH, CAH, TOA, SOHCAHTOA. You can use all those and apply those to the problem. Okay. Here's this opposite side, hypotenuse here. So that means I'm going to do sine. So sine 60 equals x over 8. Figure out what sine 60 is. Cross multiply with 8. So x is about 6.9 inches. Sorry, nope, centimeters label. Okay, so once I know that, I just plug it in my area formula of 14 times 6.9. And since it's just a parallelogram, I don't divide by 2, so 6.9 times 14. The area is 96.6 centimeters squared. All right, this last one here. Now, this is presumably a trapezoid, but don't necessarily know that. We haven't done trapezoids yet, so let's break this into shapes. So I have a triangle here, so I know the area of the triangle is base times height over 2. This is my height, this is my base. So you can do Pythagorean theorem to get it, or know your triples of 5, 12, 13, so this side is 5. Okay, so for the area of this, I'm going to do 5 times 12 divided by 2, so I get 30 for the area of just that triangle. Again, some of the problems like you did yesterday, if I drop this down, I want something familiar, so I drop it down. Since I have a 13 on the end, if I have this height here on the left, it's also the same on the right. So I know that's a 12, this is a 5, and the area on each end will be the same. Now lastly, the inside here part, I have a rectangle. So rectangle was base times height. So 12 times 18. So 216. So to get my total area, I'm going to add up my 3 parts. 30 plus 30 plus 216. And what do we get? 60 plus 216 is 276 inches squared. All right, that's the notes for today. So on the other side, for tomorrow, complete the other side. It has a bunch of different triangles on it. It has some you might want to do trig or the 30, 60, 90. It has some composite or compound shapes where you have to do multiple shapes. So get those finished for tomorrow, and I'll see you Friday. Bye.